Welcome and hello to our today's webinar here at Fronius. So my name is Christoph Schillinger, and I will guide you through this webinar today with the topic Fronius Tauro Design and Installation. Before I want to show you some agenda details, I want to introduce the rest of the team for today. So I'm not alone today. My colleague Sandro Köhl is helping me, so he's actually responsible for the chat today. So here is my first request to you, dear audience. If you have any questions, use the chat function, please, and send your questions directly to Sandro. He will then try to answer as good and quick as possible. And as usual, at the end of the webinar, we will take a few minutes time to maybe answer a few of your questions live if you have one. Yeah, so we are both at the team Trainings and Education, and today I want to go through the slides with you today for the next 30 to 40 minutes, something like this. And I have the following agenda topics for you. We start with a few hard facts about the Tauro and the Tauro ECO. Then we go to a new design tool, the Fronius Tauro Configurator. This tool is actually meant for helping you in the ordering process to help to find the correct variants and options available for this product, and to also find the correct ordering number for you to send to the wholesaler. Next up is the installation instruction of this product, and followed by the Fronius Smart Meter, of course, a very important tool. And last but not least, we will have the commissioning process of the Tauro and the service process. So we will start directly with the hard facts of the Fronius Tauro. So as you maybe already have heard, we will have two Tauro devices, the so-called Fronius Tauro and the Tauro ECO. So this one is the first one, the Fronius Tauro, and it will come in the power class 50 kilowatt. And it's gonna have an MPP voltage range of 400 to 870 volts on the DC side, with 3 MPP trackers in total. And the input currents for those 3 MPP trackers are 36 on the first two and 72 on the third one. So this is the Fronius Tauro, which will actually come in a few weeks. The Fronius Tauro ECO is already in production, and this is the next product I want to show you here. The Fronius Tauro ECO is available in the power classes 50 and 100 kilowatt, so even a little bit bigger. And we will have a little bit limited voltage range compared to the Fronius Tauro of 580 to 930 volts with 1 MPP tracker. So that's one of the main differences between those two products, 3 and 1 MPP trackers. Yeah, and for the input current, we can see here on the 50 kilowatt device, we have 87.5 amps, and for the 100 kV device, it's 175 amps. Yeah, we will have tools, products for all different kind of scenarios out there, so different topologies, and we have two of the usual topologies listed here. There is usually a central system design for such big systems or a decentral system design. And the big difference is the location of the tool, of the Tauro. So on the central system design, we can see here the Tauro is located at one place. They're all gathered at one central position, and there we run with bigger DC cables to the main arrays where we have DC combiner boxes, and from there then the arrays are connected to this DC combiner box. So the main difference between central and decentral is the position, as we can see here, because on the decentral position we have the Tauros distributed across the field. They are near the modules, and therefore we can usually connect the module arrays directly to the Tauro with MC4 plugs. So as we can already hear from this explanation here, we need a different connection possibilities for those two topologies. And luckily, we have this option for the Tauro. So the first one is the central system design, which is at Fronius let's skip this. For the central system design, we have the pre-combined variant of the Tauro. So we think back again one slide before, we have seen a central position of all the inverters and big DC cable coming from the DC combiner boxes. And these can be integrated on the Tauro or can be connected on the Tauro with big cable inlets. And inside of the inverter, we have big V-clamps, which can clamp down up to 95 square millimeters of DC cable. So this is the first option for the first topology, and the second topology, the decentral system design, where we install near the modules, is called the direct variant, short D. And here we have integrated MC4 plugs for directly connecting the strings. So on both of the devices, we have a huge AC cable option cross-section that we can connect. On both of them, it's up to 240 square millimeters, which we can connect. And yeah, as we can see here, we have two topologies, which we can provide here with the P or the D option of the Tauro. Yeah, how to find this option? This is actually then a job for our new Tauro configurator. This configurator can be accessed here just with the link above, or you just type it into your browser, Tauro Configurator, and you should be able to find it. And this tool is really to find your customized project inverter with all the tools and options available and necessary, and also to find the correct ordering number. So I want to show you some screenshots how this is working. First of all, you go through the tool and select step by step what you want. Is it a central or a decentral topology? You select the inverter type, fuses, surge protection, AC connection, and if you want to use the AC disconnector option or not. And after that, you will get a summary of your options with the ordering number next to it. So this is the first major step for you to be able to order this via the wholesaler. Then you can select, of course, the quantities that you want. And last but not least, you will find this here. You can export your configuration and send it to your wholesaler, or you can directly email it. And of course, you can also use this button down below with Find My Nearest Sales Partner. So this should really help you to order the correct Tauro with the correct options for your project. So now let's take a closer look into the installation instructions of the Fronius Tauro. And yeah, of course, first of all, we need to know what tools do we need or what components do we need for the installation. And for the tools, it's necessary to have a flat tip screwdriver, a Torx 20 and a Torx 25 screwdriver. With these three screwdrivers, we can open every component here on this product. And yes, usually we don't use electric screwdrivers on our tools because you can damage the screw or the nut. But there are several screws on this product, and if you have a screwdriver with torque, you can use it, of course, for the many screws that we have in a service case, for example. So this is no problem then to also use an electric screwdriver with torque. The quick start guide is delivered within the package. If you need a more detailed one, you can check out our homepage and search for installation instructions. And for online updates, we usually do it like this. We install and commission the product and bring it online onto SolarWeb. This is our visualization portal. And then as soon as it's online there, you can do the online update from wherever you are, from your office, and you can do it also regularly if you want. Or if you want to do it on site at the installation process, of course, you can do it in the commissioning step via the web interface of the inverter. So this is also no problem. Yeah, regarding the instructions, where can we install this product? In and outdoor is no problem. We can see the ambient temperature range goes from -40 up to +60 degrees Celsius, so a huge range for this tool. However, if you want to use the AC disconnector option, you have a little bit limited ambient temperature range from -25 up to +60. But overall, I think it's plenty enough to install in most areas where you want to install such a system. Regarding the humidity, we also have no problem here with our high IP class, IP protection class of 65. And regarding altitude, we can install up to 4,000 meters above sea level without any restrictions on the DC side, on the voltage. Regarding the installation side, as mentioned, indoor or outdoor is no problem with the IP65 class, and also the altitude I've mentioned up to 4,000 meters without restrictions. We have an actively cooled system, so there is some noise, and this is why we don't recommend to install it in living areas, of course. And also it's not very good to install it in areas with high dust production because the cooling channels might be trapped. So yeah, we need to make sure that it's not so dusty there. In the second row here, we can see a direct sunlight installation is possible with the Fronius Tauro. This is actually a first one for our products. So in direct sunlight next to the modules, for example, it's no problem without any restrictions. However, it is of course better to install it in a shaded area to have an even cooler inverter and an even cooler component. Yeah, so both of them are possible. However, it's, for example, better to install it underneath the modules or to just put a little cover or a shade cover on top of the inverter. Yeah, areas with a high corrosive components in the air are also not that good for the inverter. And everywhere where we have livestock, which is able to knock the inverter down, there it's of course also not very recommended to install it there. There it's better to use the second building next to it, for example. Yeah, and also in greenhouses, it tends to be a little bit warmer than outdoors. So also there we don't want to install it necessarily. For the orientation, we can install it vertically up to horizontally without any problems. However, we need to make sure that it's not tilted sideways, because sideways we would have the problem that the cable glands at the bottom are not tight enough, for example, so there would be a risk that water finds its way into the inverter. So of course we don't want that, and therefore we just need to make sure that it's correctly installed and not tilted sideways. That's the only restriction here. We also have an option called floor racks, and these floor racks can be ordered with the inverter. So it's not coming as standard. You can order it as an option, and you just stack them inside of the inverter left and right, and you would be able to have a floor mounted system here next to the modules, for example, on a roof without any problems. And you can see here on this picture, it's slightly tilted so that the water and snow can run off easily, for example. And yeah, so you can use this option for a floor mounting of this product. Please make sure to keep the clearance if you install multiple inverters next to each other, or if there are other objects next to the inverter. Because we have the actively cooled system, of course, we get rid of hot air at the side of the inverter and on top as well. And therefore we need, of course, some clearance to have this distribution of the hot air. So just keep in mind 50 centimeters on all sides, and then we are perfectly fine for other inverters or other components installed next to it. Yeah, regarding the installation process, it's rather easy. We have such a wall mounting bracket, like we can see here in the schematic on the left. And this is just fixed to the wall with a minimum of 4 screws. And then you hang in the actual inverter and tighten it down with 2 screws at the bottom. And that's it actually. That's the whole installation process. However, I have a short video for you here. Let's watch it. It's just 1 or 2 minutes. So as we can see here now, we lift the product up, minimum of 3 people, hang it in, and then at the bottom, we have 2 fixing screws to keep it on the wall bracket so it's not able to fall off again. And that's actually it. That's the whole process that we need to do. Okay, also for transport and lifting, we have some options here. We can use the predefined eyelets on top of the inverter, for example, to mount cable, to mount a chain to it and to lift it up with a crane on top of a roof, for example. So therefore, we could use these eyelets. We just need to make sure to not have any erratic movements so that the inverter or some components inside get loose, but that's all. And yeah, as I've mentioned, 3 people are necessary for the smaller devices. For the 50 kilowatt devices, you could do it with 2 people, but I think with 3 people, it's better to move and install the product. Yeah, I've already explained that we have an active cool system, but what we can see here now is also a double wall concept, which is also quite new for Fronius on this product. And the double wall concept, as we can see in this picture, is really a doubled layer of metal sheet at the front of the inverter. So it has a doubled layer, and therefore we can also install it in direct sunlight without any problem. And we can still have a cooler temperature inside, despite being having a direct sunlight on the inverter. So with this double wall concept, we of course have a maximum service life despite the heat. And yeah, it's because of this double walled insulation here. And without this doubled layer, we would have 13.5 degrees of Celsius more on the product. So it really does make a difference to have this doubled layer in front of the front layer here. So it does make a difference. And we can have full performance up to plus 50 degrees of ambient temperature without power derating. So this is really a high performance up to a high ambient temperature range compared to a passively cooled system, for example. Yeah, and of course, it's a longer service life, which means the components are in a cooler environment than we would have, for example, without the double wall concept, and therefore also the lifetime is expanded here. Yeah, and here again, we have a crosscut through the whole inverter, and we can see here the actively cooled system. It's sucking in the cold air from the front with 1 or 2 fans, depending on how much power stacks you have inside. And the hot air is then distributed all across the inverter and also through these double wall concept where the hot air gets rid of. So this is how the concept is working. Yeah, let's step on now to the actual installation, the cabling of the Tauro. And yeah, for the DC string configuration, I highly want to recommend to use the Tauro Configurator. Maybe you already have heard from this tool or used it even. It's a free of charge online tool for all of our inverters of Fronius. And of course, also the Tauro can be configured with it. Here is a screenshot on the right-hand side. And really what the main focus of this tool is to not exceed any limits. For example, the 1000 volts, to not exceed any current limits, to not exceed any power limits on the inverter. It's really in a few steps that you can make sure to not exceed any limits, and then you can go on to more integrated tools, for example, PV-Syst and PV-Sol, where you would have even more detailed answers like yield, forecast, and so on, which can be quite commonly asked for from the customers. So if you have such tool in use, please also make sure to have a quick look at the Fronius solar configurator and then go to PVsys or PVSol, for example. Yeah, regarding the numbers, we have a DC input voltage range on the Fronius Tauro, the standard version with 3 MPP trackers of 200 to 1000 volts. And on the Fronius Tauro ECO, 50 or 100 kV, we have 580 up to 1000 volts. So this would be a limit, the 1000 volts, which we need to make sure to not exceed. What we also have on all of our products is a oversizing possibility. So as we can see here, the PV generator can be oversized to 150%. So this means on a 50 kilowatt device, we can mount 75 kilowatt peak without any problem. The only thing we need to make sure is the 1000 volts, not to exceed that, and also that the current, the maximum current of the MPP tracker and the strings itself is not exceeded. Yeah, and I've already explained you can use PVsys and PVSol because this product, the Tauro, is already fully integrated in those two tools. So for a more detailed overview like yield forecast and so on, you can of course use those tools as well. And as I mentioned, please also check out the solar configurator. If you want to know more about the whole tool scenario, you can of course check out a training that we offer in this regard. It's a special training day, a full training day on the Tauro, where we talk about how to design with those tools and what's the difference. And yeah, so if you're interested, just check out the homepage and register. Okay, now in a little bit more detail, how is it looking on the DC side on a Fronius Tauro direct variant? So we recall the direct variant means we have a decentral system topology where the product, the Tauro, is distributed across the field and installed directly to the strings of our PV arrays. And there we can see, of course, we have MC4 plugs. That's the main difference on the direct version. And on the Tauro standard and the Tauro ECO 50, we have 14 strings. And on the Tauro ECO 100 kilowatt device, we have 22 strings. So on the far right, we can see here how it's looking like. On the 50 kV device, we have 3 MPP trackers, as we recall, and we have those connections available here. On the 50 ECO, we have only 1 MPP tracker, but it's split up in PV1 and PV2. This is just because of the DC disconnectors. So we have 2 DC disconnectors on this product. And on the Tauro ECO 100, we would have 3 DC disconnectors. That's the reason why it's split up in 3 parts here. However, we only have 1 MPP tracker available and 22 string connections. There is the option to integrate fuses again. So you can choose between 15 amps or 20 amp fuses. That's of course depending on the right dimensioning. So on the module you're using, for example, on a 10 amp string, on a maximum of 10 amp per string, you would use the 15 amp fuses. If you have 12 amp per string, you would go for the 20 amp fuses. Let's have the same closer look on the Tauro precombined, short P. And the precombined is again the topology for a direct version where we have a central version where all the inverters are collected at one place, and we have bigger DC cables coming from the DC combiner boxes from our field. And there we have those V-clamps. Here is a schematic how this looks like. And these V-clamps can handle up to 95 square millimeters on the DC side. And as we can see here down below, this is how it looks like with the cable glands. On the Fronius Tauro ECO 50 and 100 kilowatt device, we also have 6 cable glands, but we only use 4 of them for 2 string connections. And for the Tauro 50 kV, we have, if we recall correctly, we have 3 MPP trackers. Therefore, we have 3 string connections, and we use all 6 of the cable glands. That's a small difference as well here in the products. And yeah, if we install it, we go through the cable glands. Inside, we install on the V-clamp, and please always make sure to torque correctly. We have a torque here, a recommended torque of 32 Newton meters on the DC side. Yeah, there is the option of an integrated surge protection device. On the picture here, we can see it here. And yeah, as standard integrated, we do have a type 1+2 as SPD integrated on AC and DC side. However, for any reason you want to only have type 2 integrated, you can do this in the ordering process and say, okay, I don't want to have type 1 and 2, which would be standardized. I want to have type 2, then you can order it as an option. And these are integrated then here on this thin rail on top here. Yeah, let's take now a closer look on the AC side of the inverter. We have actually in total 3 different options choosable. The first one is called a single core option. So we have really on the AC side, this is now the right side, when we look at the bottom of the inverter, we have 5 separate cable glands for entering the product on the AC side. And this would be, of course, a common use. The second option would be a multi-core cable, which is also quite often used in such big commercial inverter plants. And in the multi-core cable option, we can see here, there is one big cable gland, and usually the grounding cable comes separately, which is the reason for the second cable gland here next to it. And last but not least, there is also an option called AC daisy chaining. This is actually 10 times a single cable inlet and also 10 times V-clamps inside. So going one slide ahead, I want to explain a little bit more in detail what this means, the AC daisy chaining. This is actually a cool innovation for this product. And shortly explained on this picture here, we have now the opportunity to cable multiple inverters on the AC side together. So for example, we are coming here from the main distribution frame and going to this inverter here. We are connected here and go from the second set of V-clamps to a second Tauro. And therefore we save, of course, a lot of cable costs. Let me explain in a little bit more detail what this means. Of course, we have some limitations here, and the limitation is 200 kilowatt can be maximally interconnected. So this can mean 2 times 100 kV devices. So this would be the picture of, for example, or 4 times 50 kV devices, which can be seen in the schematic here. So we really go from one device to the next one, to the next and the next, and only from the last one we then connect to the main distribution frame. And in total, what we do here is, of course, save a lot of cables because we don't need to run the full length to the main distribution frame every single time. And also we save a few components. If you think about it, you do have a code in your region, for example, which states that you have an AC disconnector on every component that you install, on every inverter. So if you would singly cable every single inverter to the main distribution frame, you would need 4 AC disconnectors per line. And in our case, we only have one line here to the main distribution frame, and we can set one centrally positioned AC disconnector here in this line and save 3 AC disconnectors in that regard. So we do not only save cable costs on cable length, and but we also save on components required. So yeah, this is called the AC daisy chaining option, and you can order it as an option. Yeah, we always talked about the V-clamps already. The V-clamps are looking like this, and they have a little bit of a cool feature. You can flip the V-clamp and rotate it, and then you have different sizes or different cross sections of cable possible to connect to it. So in the one place of the V-clamp, you can clamp 25 to 150, and then you turn it around 180 and you have a bigger V-clamp available, which you can use for 185 to 240 square millimeters. So really nice feature here and very easy to do and fast to do as well. Yeah, on the AC side, we do have recommendations for the cross section that you're using. Looking at the 50 kV device of the Tauro, you can use, of course, copper and aluminum cables on the AC side. That's no problem. You can use both of them. And doesn't matter if you use a standard version, single or multi-core, or if you're choosing a AC disconnector or a daisy chain option, the minimum cable you should use is 35 square millimeter, going up to 240. And for a 100 kV device, again, you can use copper or aluminum. However, the minimum size is here 70 square millimeters on the AC side, because of course, double the current, double the power is running over this cable. So therefore, 70 to 240 square millimeter is recommended to use for the 100 kV device. Okay, stepping ahead to another very important topic, which is called the Fronius Smart Meter. And the Fronius Smart Meter usually sits at the feed-in point of our system and measures all the energy flows. So what do we feed into the system and what maybe is used from the grid, and it then uses this data and sends it to the Tauro device, which is then using it to send it to SolarWeb. And then the customer has a cool visualization of what's going on regarding the energy flows within the system. Yeah, for the Tauro device, there is one specially matching smart meter, which is called the Fronius Smart Meter TS 5 kiloampere. We do have smaller ones as well for residential, but this is really meant for bigger systems, for commercial systems like we have with the Tauro. And yeah, as we can see, for the 5 kiloampere smart meter, we do need external current transducers. So as we can see here, these are ones that we can simply clip over the phases so that we don't have to cut them open and feed them through. But there are many out in the market. And soon in the near future, we will also have a guide helping you to decide what current transducers to use here. Yeah, and as we can see, the current transducers are mounted or connected here on top of the inverter. And at the bottom, we can see here a 3 dotted line here, which is the Modbus communication. So this is actually our communication line from the smart meter to the Tauro device. And within the Tauro device, we have our data communication. This is actually the brain of the inverter. And it's the same component that we also have for the Gen 24 devices. So you may be already familiar with this tool. And this is called the pilot. The pilot, as I've mentioned, is the brain of the system. And we have 3 orange plugs here. And the middle one, it states Modbus on top here. This is where we, of course, want to connect our 3-pole line here. So in this yellow box here, we can see the pins that are necessary to connect to. And we can see here, we have 2 separate Modbus connections, Modbus 0 and Modbus 1. You can choose which one you want to cable to. It's really the same thing, but double the amount. And we have Modbus 0 minus and Modbus 0 plus, of course, and then a grounding cable. These are the 3 connections that we need for our Modbus line. Now I want to talk about 3 very important topics which you always need to consider when doing a Modbus communication with Fronius. And the first one is use a Cat5, standard Cat5 cable at minimum. Of course, it's even better to use a Cat6 or Cat7 Ethernet cable, but Cat5 is the minimum that you should use. The reason is that we have a twisted cable, and this twisted cable should be used between Modbus plus and Modbus 0. So between green and yellow in my scenario here, we want to have a twisted cable pair to have the maximum of data security available. So this is the first, use the twisted cable pair between plus and minus. The second very important topic is to ground the shield on one side. A Cat5 cable or a higher standard does have a shield on the cable, and we need to make sure to ground it on one side, which is no problem on the Tauro side, because actually we also have one prepared here, a separate plug, a pin here, which is already called shield. And this is meant exactly for that, to put the ground, to shield the ground on one side here. This is topic number 2. And the third one is, please make sure to set the 120 ohm resistor at the end of our data communication. So on a Modbus line, we have a serial connection of components, and at the end, we always need to make sure to set the 120 ohm resistor. So in our case, it's the smart meter and the Tauro device. And here we have a very easy way to do this on the smart meter, because the 120 ohm termination resistance is already set within the Tauro. It's already built in. And the only thing we need to do is to set a small cable bridge here, like we can see here, and then we have activated it. So that's a very fast and easy way to do it on the smart meter. And on the inverter, we have on top here, above the orange plug, we have a small dip switch, which we need to set to on, or the 1 position. And then also here we have set the 120 ohm resistor. So these are 3 very important topics. Please always remember them to have the correct and the best available data communication possible. Yeah, the next step is, of course, to set the current the transformation ratio, because it's depending on the type of current transducers you're using, what the ratio is. And the ratio can be set as the following. We need to go on the display on the smart meter to page 1. So we have up and down button, and in the middle we have a enter button. And we need to go to page 1, type in a password 2633. That's always the same password on every Fronius smart meter. And when entering the password, we go to page 4 with the up and down buttons, where it states current ratio. And there we then need to set the correct ratio of our current transducers. For example, in our case, we have a calculated transformation ratio from primary to secondary of 50 to 5, which is 10, and therefore we need to set 0010. Then we press enter again and we leave this page, and then we are set and ready to go. Yeah, the last step, of course, would be to activate the smart meter at the web interface of the Tauro. This would be then done in the commissioning process. But before we go to the commissioning process, I quickly want to show you how the data communication of the Fronius Tauro actually works. And the first thing we can see here is an already known picture of the Tauro device with the brain, as I always call it, the data communication unit. This is the pilot, how we call it internally. And this is where we have our Modbus communication. We also have a LAN port where we can connect to the router, or we can use, of course, the Wi-Fi function to connect to the router. And this tool is also the tool where we do the commissioning with. So we either connect via Wi-Fi or via LAN and do the setup of the inverter. So this is actually our first step now. Before we do that, a quick overview on the Modbus. Again, this is the middle of the orange plug here, and we do have 2 separate Modbus communication interfaces here, called Modbus 0 and Modbus 1. We also have 12-volt DC signals here, a grounding connection, and also a shielding possibility. Yeah, and don't forget the 120 ohm resistor is sitting on top here with these 2 small dip switches. This is, why do we have 2 here? This is because we have 2 Modbus interfaces. So depending on if you are using Modbus 0 or Modbus 1, you need to set the correct dip switch here on top. Yeah, regarding the network, there are of course a few ways how you can do this network connection for the Tauro. Here is one of the most practical options to do so. And as we can see here, we have used LAN switches. One main LAN switch is sitting here at the central position, where we have a router connected to the internet, and to this LAN switch we have then connected the inverters directly, or if it's too far away, the distance is too far, we can also use a secondary LAN switch again here, where we then connect all the inverters directly to it. So this is really a real-life scenario. We have used this scenario here and built a system like that. And we have the main LAN switch here, and we are going here a little bit further away, so it's too long of a distance. And we have 3 separate LAN boxes here, Ethernet switches again, where we have singly connected every inverter individually to one of those LAN switches. So as you can see here, the main advantage is, of course, if one of the products is failing, there is no serial connection and the whole system would stop. All the other devices would still run, only the one which is failing would be not producing. So this is even more critical if you have, for example, a plant controller, which is stating your devices on how much they can feed in, for example. This would be, of course, very crucial if these rules won't be followed again. And this is no problem with this network connection, because if one device is failing, it doesn't matter because all the other ones are still connected. They all have network and plant controller connections, and they are following the guides and the rules of the plant controller without any problem. Yeah, and there is also a feature called PoE, Power over Ethernet, which is of course a very nice feature because usually on a LAN switch you would need a separate power line to power up this LAN switch. So it's a separate 12 or 24 volt power supply for this LAN switch. And with Power over Ethernet, you do not need this because the LAN switch is powered over the Ethernet connection itself. So just thinking about setting up such a system, it's much easier because you don't need to run a separate cable to power up the switches. You just need to wire the LAN, the Ethernet cable to the actual LAN switches, and you already have your power supply. So also here there are a few options available. This is just how we did it once in this scenario. And as well, I have here some detailed overview of the products internally positioned. So this is another cool advantage because right next to the SPD here, we have a little bit of a free space, which can be used exactly for that. And in our example, we have used MikroTik LAN switches, and we have set them into the inverter so that we don't use a separate outdoor box, which would be, of course, no problem at all. But in our case, we used the free space inside of the Tauro and placed it there. Okay, so that's actually a quick conclusion about the data communication and what we need to look out for. And now we go to the last step, which is the commissioning. And first of all, we need, of course, to know how does the inverter communicate. And this is done via the data communication. We are again at the brain of the inverter again, because this is actually also where we have our LED status and our light sensory button. So if you are familiar with our Gen24 product, this is exactly the same feature. We have an operation LED at the front of the inverter visible and also a communication LED. And between those two LEDs, we have a light sensory button. And the first thing we want to do when we do the commissioning is, of course, we want to supply it with DC and AC. Then the whole thing starts blinking. And the first thing we want to do is we press this light sensory button once for about 1 second. And then the communication LED starts blinking blue. It starts flashing, which means that the access point is open and we can now use our the phone, for example, a tablet or a laptop, and we can search for the open Wi-Fi access point. So this is our second step now. We can use the app that we have provided for you. It's called SolarStart app if you want to use your mobile device or your tablet. It can be used on Android or Apple devices without any problem. And the cool feature, if you're using the Solar Start app for the commissioning, is that it's automatically searching for this open Wi-Fi access point. So this means that you don't need to enter a password and you are automatically connecting with this open access point, and then you can proceed with the 3 easy steps: network, product, and SolarWeb. If you don't want to use the app, your mobile device, you can, of course, as usual, use your laptop and you do the installation via the browser. If you want to use the laptop, it's also a very easy step here. You open the access point again on the inverter, search for the open access point on your laptop. The name of the network is Fronius _ and the serial number. The serial number you can find on the side of the inverter on the nameplate. And then you need to type in a password. It's just the numbers 1 to 8. And after that, we have established the connection to the inverter. We open our browser. We can highly recommend there to use the Google Chrome browser. And in this address bar, you type in this IP address. That's the same IP address for all of Fronius inverters. So it doesn't change, it's the same. And after entering it, you will come to the same step as you would have with the Solar Start app. You will see network, product, and SolarWeb. Those 3 steps are our commissioning guide. We follow the steps in those 3 topics here, and then we are finished with the commissioning. However, there is even a 3rd step which you can choose, which is a LAN connection. If you, for example, want to use a direct LAN connection to your laptop, you just open the device and set your cable, your LAN cable, to the LAN 1 port. Please make sure to always use the LAN 1 because we have LAN 2 as well, but this is only used internally. It's not meant for the commissioning process. And after setting up this LAN connection, we again open the Google Chrome browser and we type in this IP address and do the same following steps: network, product, and SolarWeb. And then we're done with the commissioning. So as we can see, there are a varieties of commissioning options available for you, and you can choose whatever you want here. Okay, coming to the last step now, to maintenance and service of the product. We have, of course, a cool feature here which makes it much faster and easier to do the service, which is the component exchange. You can exchange mostly every component in this inverter, and the heaviest one is 25 kilogram. This is the power stack itself, which can be done by 1 person. And of course, it saves a lot of time and labor costs to only arrive here at the site by 1 person instead of a whole service team. And it's also much faster to exchange 1 component than the whole inverter. Yeah, that makes the whole system, of course, much faster in field if there is a service to do. We also have a tool available for you. It's called Solar SOS. Again, this is a browser version as well available for you, but you can use the app as well. And it's perfect for you as installer to have a fast troubleshooting available. You can do a fast ordering process of the necessary exchange components that you want. You have an overview of all cases and orders that you have done. The manuals are shown for you and listed for you on the current product you want to search for. And you even get an automatic notification if your exchange component is in delivery or if it's already shipped. Yeah, and that's it actually for the maintenance and the service part. So as we can see, it's it offers a variety of savings here as well for you. And yeah, we are at the end now of our webinar. I quickly want to open the question center and see if there are any questions, because at the end now, I want to take just 1 minute and ask my colleague, Sandro, do we have any questions right now that we can answer live?
Hello, Chris. Yes, thanks a lot for your presentation so far. Yes, we have received one very interesting question, which I would like to point out at this stage. So there was one question: is it possible to use the Fronius Tauro for feed-in limitation? So that was something which was not mentioned during the presentation, but of course, yes, it is possible to realize feed-in management with the Fronius Tauro. So it always depends on the size of the PV array and the requirements of the grid supplier. So you cannot say it in general terms here, but in some cases it can be done via the Tauros directly. So depending again on the size of the plant and on the requirements. And in other scenarios, when it comes to a more complex system with multiple Tauro inverters installed, you have to rely on an external plant controller. Yes, but generally said, feed-in limitation and feed-in management with the Tauro is possible.
Okay, thank you very much for the question and also for the answer, Sandro. Thank you very much. On that point, that reminds me, of course, I have one slide left here that we can see here. If you want more information, you can, of course, always check out our homepage. And if I recall correctly, we are working currently on a paper which actually tells us on which power plant size we need to use a power plant controller, or where we can do it internally with our product. So the same thing as Sandro just explained is written down then in this one application paper and is available for you soon via homepage. And yeah, on the homepage you of course can find the next educational topics that we have provided for you, like online trainings are coming up, and also if you can travel to Austria, we are also happy to invite you to a training here. Yeah, so just check out our homepage for more informations on that regard. Okay, last but not least, that's it actually. If more questions arise from you now, please use the chat function and type them in, send them through. We will stay online for you. We will just mute ourselves now and write you back. And yeah, on that point, I want to thank you all for joining today, for your question as well. And thank you, Sandro, again for helping out today. Hope to see you guys in the next one then. Goodbye, guys.